All right, here we go. At the top of your paper is 6.2. This is called simplifying radicals. So yesterday, we simplified perfect radicals. So our answers came out to just a number, okay? Today, which is also review, they will not come out to a perfect number. So I will show you the easiest way to do this. If you do it my way, that's fine. If you know your perfect squares, then you can do it a different way, but I'm not teaching it that way, okay? So square root of 150. I'm going to break it down into its prime numbers. So any two things that multiply to give me 150. So I can have 15 and 10. What else could I have had? 25 and 6. No 150 and 1. That defeats the purpose of breaking down 150. Could have had 50 and 3, right? So I could have had a bunch of different things. Then I'm going to break each of these down. 15 can break down to 5 times 3. 5 cannot break down, so I circle it. 3 cannot break down, so I circle it. 10 breaks down into 2 and 5. 2 gets circled and 5 gets circled. So when I rewrite my radical, everything that is circled will go inside. 2 times 3 times 5 times 5. And then what's the whole point of having a perfect square? It's two numbers that are exactly the same. So in order to take a number out, I have to have two numbers that are exactly the same. So my 5s can come outside. So my final answer would say 5 square root of 6. Where did 6 come from? 2 times 3. Okay. So the next one would tell me square root of 9x to the 5th. Well, 9's a perfect square. I should know that one, but just in case, I have 3 times 3. And so when I rewrite my radical, until you catch on, you can write it like this: 3 times 3, and then I have 5 x's. I need groups of how many to take out. So I can take out a group of 3. I can take out an x. I can take out an x. So on the outside, I have 3 times x, which equals 3x squared, square root of x. Okay. If you don't have to write all this out, then that's fine. Like if you can look at it and see what the answer is, then that's fine. Okay. So try this one: square root of 32, x to the 8th, y to the 7th. I'll break it down in case you need to do so, and then look up and check your answer. So what do I have outside? 4x to the 4th, y cubed, and what's left inside? 2y. Okay. Now, the letters take a long time to write out. So hopefully you understand that if I have groups of 2, I'm just dividing by what number? 2 for letters only. You can't do that for numbers, okay? So like if I had x to the 12th, how many sets of 2 can I take out? 6 sets, okay? All right, so let's go this direction. Let's do this one. 3 square roots of 24. So all I'm doing is breaking down my 24, 2 and 12. Doesn't matter. Did I have to use 2 and 12? No, you could use other numbers. Okay. So I broke down all my numbers. When I rewrite this, this 3 has to stay outside. It's part of the problem. So I have 2 times 2 times 2 times 3. I can take out a group of 2. Now what happens to everything outside? It's multiplied. So what number's on the outside now? 6 square roots of 6. Okay. So try this one on your own, and then I'm going to show you one different thing. Oops. Negative 2x squared square root 72x cubed. Anybody else get that answer? Yes, no, maybe. Where did I get negative 12 from? The 2 times 3 is 6 times negative 2 is a negative 12. X cubed is because I already had 2 x's outside, with one more would give me x cubed, and then inside is just 2x left over. Yes? Okay, so let me show you the last type. So you will also get questions that look like this. It'll say big square root of x to the 7th over y to the 6th. So the very first thing I suggest you do is ask yourself, in my fraction, are there perfect squares? Okay. So in this fraction, there's no number, so there's no perfect number of a square. So if you don't have any perfect squares, then ask yourself, can I reduce the fraction? Well, this fraction can't change because there's nothing similar. So I can rewrite this as square root of x to the 7th over square root of y to the 6th. If I have 7 x's on top, how many groups of 2 can I take out? So I can take out 3 groups, but how many are left over? 1. All over in my denominator, I have 6 y's. How many groups of 2 can I take out? 3 of them. Can anything simplify or cancel? No. Okay. But let's go look at this one. This would be your final answer. Yes, today. So let's go try this last one, and then you'll be on your own. Square roots of 32x to the 6th over 2x. Is 32 a perfect square? Is 2 a perfect square? No, neither one of those are perfect squares. So I would try to simplify my fraction. So what is 32 divided by 2? 16. What is x to the 6th divided by x? No, x to the 5th. So now I can ask myself and break it down. 16 is a perfect square, but if you didn't know, you can do your 4 times 4 and get your numbers. So 4 is my perfect square outside. If I have 5 x's, how many groups of 2 can I take out? So x squared would be outside, and what would be left inside? X. Questions? Okay. Your practice is on Delta Math. I don't know. Don't forget that you have homework that is due at 3 p.m. today. If you haven't done it, I get it done. Okay. On Monday, we will talk about nth roots. Excuse me. It just means it's bigger than groups of 2.